All right, welcome back. I hope you're having an amazing show so far. Our next speaker is Matthew Versaggi. He is Senior Director of Artificial Intelligence and Cognitive Technology at Optum Technology and United Healthcare. Please join me in welcoming Matthew to our virtual stage.
Thank you very much. I'm just going to start sharing my screen and we can get started. And sorry about that. I'm going to go back up to the top. So we're going to talk about quantum computing today and how that relates to the healthcare space, and give you a solid virtual tour of all that's in that space, and hopefully give you context in which to really understand how quantum intersects with healthcare, how that's an extension of the AI space, and all the really interesting things that go in there. So what we'll do today is we're going to do a quick quantum refresher for those of you who aren't used to it. We'll bring you up to speed. We'll talk about why we care about quantum, and then we'll dig into the richness of the healthcare space. We'll take a look at how you can start it quickly if you want to get your organization started in this. We'll pass over the education front into events of note in the healthcare space for quantum, and then some of the lessons we learned so far, as well as strategic alliances and why they're so important. And we're going to do that in 20 minutes. We'll pass on the demos because we just don't have that much time. But let's get right into it. So if you want to look at quantum relative to classical computing, the key issues is that we're swapping out the underlying computational hardware that you have in the classical world with subatomic particles. And so instead of using bits and bits and silicon wafer chips, we'll use subatomic particles to do information processing on, and that changes the game as well. There's a number of reasons why that's a very important thing for us to do. But what that gives us are things that just don't exist in the classical world. Like we're actually doing information processing on neutrons and protons, subatomic particles of various sorts. It gives us quantum waves, gives us this thing called a qubit as opposed to a regular bit. We have a quantum bit. We have on and off like a regular bit does, but then we've got everything in the middle. And that happens when we spin it up in the superposition. These are things that just have no classical doppelganger. Things like quantum interference allow us to compute differently, not faster, smaller, better, but differently altogether. We have things like quantum entanglement and quantum teleportation that have no aspects in the classical world. And we have to really kind of change our mindset to begin to entertain these things in the quantum world. Now, it doesn't come without its distractors either. So quantum waves are unstable right now. That's the crux point. You have to have functions that are reversible. You can't copy qubits like you copy variables. Every time you read a qubit, you destroy the information inside of it, unlike the classical world. And it's very much like assembler programming for all folks that have had assembler programming at their point in time in life. It's very much like that. There are no hierarchical programming constructs, so there's no for loops. So what this really means at this point in time in its maturity is that quantum has a very, very restricted problem space of the kinds of problems it can solve that are either naturally quantum friendly or we force them into a quantum friendly state. That's the big takeaway here. Another thing when it comes to healthcare is that there are two camps really, folks who are producing a technology and folks who are consuming it. This producer side is huge right now. 99% of the materials are created for that. And the consumer side is very, very small. This will flip in time. The consumer side will get very large and the producer side will get much smaller. Just know that that's coming. And if you're in the healthcare space, you are definitely in the consumer side. So that's important to know. Now, why do we care about quantum computing? It used to be just a passing fancy, just a few years ago. But now there's a big geopolitical fight going on the AI side, as well as quantum computing between the US and China, as well as others. But these are the main groups that are engaged in that conflict. And what happens is that the key choke point is the material science to hold subatomic particles long enough to do information processing on. It's just not mature. Now, because of this, mature relative to the binary world, because of this, all the physicists that have been sleeping for the last 2 decades are now being put back into service to help find solutions to that problem. And that is the problem that's holding up quantum computing from becoming a real thing or more of a real thing. And it's changing over time. For instance, there's been a recent development about diamond nitrogen vacancies. We'll look at that in a minute. Other reasons why we care is that this is not a fast follower technology. You just can't follow the next guy in really quickly and hope to do well. Everyone pays that same educational tax, and it's significant. So that's a big deal. Probably the next one is the global security concerns, and there are many. The fact that that quantum could be a bona fide threat to RSA encryption is a real thing, and we'll look at that in time. But that's one of those things that will force quantum on you, and you'll have to deal with it, as opposed to it's a passing fancy. Maybe there's some exploitable concerns there in the business world. This is where it comes knocking on the door and it makes itself known, and you have no choice but to handle that issue. That's more of a concern these days than not. So keep an eye on that one as well. Now, we talked about diamond nitrogen vacancies. One of the key things from a threat vector perspective from security folks is that right now, quantum is in these big refrigerator tubs, and you just can't have one on every street corner, so to speak. But the moment that they become room temperature, then we can spread that threat around the globe, and anyone can have these. Now, this was a recent advancement where they had a quantum accelerator just about the same size, but GPU can fit right into a regular classical machine and bring quantum power to it. Now, it's very small, just a few qubits, nothing to be worried about. However, it's the first of its kind. First time we see a room temperature quantum accelerator out there, and that allows us to see a time in which these things can be room temperature, and then they can be distributed around the globe. That expands that security threat vector a lot. So keep your eyes peeled on this one. That's a significant thing to see. So the richness of the healthcare space. We talked about why we think that quantum is important. Here's why healthcare is so rich. So in my opinion, defense and healthcare are the two richest spaces for AI as well as quantum. And so you see the standard doppelgangers here that you always hear about in this space: genomics, disease medicine, disease screening, drug interactions, all that kind of stuff. That's an outsider in journalistic looking perspective. We want to show you an inside out perspective and show you how rich it is. So when you look at innovation is really taking, much like innovation in the machine learning space. You take existing algorithms, you find new domains in which to apply those, and voila, you have innovation. And that's really kind of where things are at, because healthcare is a fairly untapped greenfield space. And so we take patterns of quantum-friendly problems with new problem domains, and voila, we've got innovation. We've got all of these use cases with us. Now, what's more is that if we think of the quantum classical relationship, that you can have a classical computer buzzing along, comes across a problem that's best suited for a quantum processor, it kicks that over to a quantum processor, it gets what it needs back, continues on, and maybe it kicks things over to a CPU or GPU or whatnot. When you look at this integration between quantum and classical, and you have to think about it this way, that opens up the aperture even further. And so the kinds of problems we can entertain even get bigger. And so when we also tack in this, when we look at the high level analysis of problems as opposed to the low level, meaning how do I put a quantum circuit on a quantum circuit board to solve this problem? When we combine it with the high levels, then the aperture even gets larger of the kind of problems we can solve. And so here they are. So aging, chronic, end-of-life care, patient personalization, precision medicine, electronic records, fraud is an enormous thing, clinical trials. We can get into genetics and genomics. We've already gotten a number of patents in that space at Optum fusing in that area, augmented decision-making, intelligent assistance. Preventative care is a huge area. Mobile healthcare is another one. Healthcare operations needs to be optimized. The Internet of medical things is a big deal. Smart hospitals, smart buildings, behavioral health, things like that. All areas where significant use cases can be found for quantum, as well as artificial intelligence, cognitive technology, and things like that. Now, if you want to get started quickly in this space, and you don't need to have a quantum background. You could do what we did, where we looked at the quantum crypto space, and we decided, well, instead of using RSA algorithms to encrypt, two areas, the server and the browser, why don't we do that with quantum safe algorithms? And we could use any one of these candidates out there and begin to understand how this would work. Now, this is what we did with the summer intern team. It took 6, maybe 8 weeks during the summer. But you can see we ran a Docker container. We built a web server that used a candidate algorithm that was quantum safe. We rebuilt the browser that picked it up, and you can see that it's using Kyber, which is a quantum safe algorithm, and it's secure all the way around. You can do these kinds of things. You don't have to know quantum inside and out to do it. You need to just be in the domain, and lots of these other kinds of projects are well within the scope of what you're doing. Now, there are certain things that you can look at on the outside with relative to healthcare and quantum, and here's some things to keep your eyes on. So, IBM is an Anthem have popped into an agreement. Those who are paying attention have seen this quite a lot. They're looking at doing all kinds of things, leveraging a quantum computer. In Europe, the Fraunhofer Competence Network is looking at cancer research with a number of other partners in that space. You'll see that happening quite a lot as well. The Cleveland Clinic was the first residential quantum computer that got installed, and they have a lot of ideas that they're going to try to implement with this. But what you'll see is quantum acting in combination with AI and cloud technologies. Quantum's never going to sit on its own. It's always going to be fused in and injected in as a viable technology in other technologies to do all kinds of neat things, from synthesizing molecules to boosting drug discovery. Now, when you look at healthcare, unfortunately, healthcare gets lumped in with, or healthcare and life sciences get lumped in together, and they are not anywhere near the same business model at all. Life sciences are much more aggressive. They'll tend to invest in newer technologies and put a lot more money in it than healthcare will, because of the nature of looking at bringing new drugs and things like that to the market. On the healthcare side, we're far more conservative. We're really a finance company that also does healthcare as well, and healthcare services. But the difference is one is very aggressive and one is very conservative. But healthcare, the life sciences space are really going to be pushing this forward in that area, and you can keep that. You can keep watching those guys for that. Now, we've done quite a bit so far. We've educated software engineers on 3 continents: Ireland, India, and the US. We've gotten 2 cohorts through, so we've got a number of patents through, a number of projects, things like that. Here's what we've learned as a healthcare company in this space. So there's a very close tie between what happened in artificial intelligence, what's going to happen in quantum, from the booms to the busts, from the winters to the booms. There's so many parallels that you can draw, that you can look at what went wrong in the advent of healthcare and pretty well predict that that's going to be exactly the kinds of stripe of things that would go wrong in the quantum space too. There's so many parallels from that. So this would be the first thing, is get to understand what went wrong in AI. I mean, AI is booming now, but it went through its booms and busts and winters and springs and things like that. It's good to know this because it's almost a verbatim one-to-one. The other thing that we've learned from technical education versus education with executives is that, when we educated the technical people on a 9-month program, for the first 8 weeks or so, even the smartest people absolutely panicked. And we had to calm them down so they can get to quiescence and actually start learning. And that's because they had no foundation to build upon. It's so new. There's so many things. These educated, brilliant people who were handpicked in an organization found themselves floundering. And we had to wait until they built enough of a basis so that they could move forward and grow from there. But they eventually did. But just get used to it. They're drinking from the fire hose, and they're going to panic for the first 8 weeks, possibly 12, until you get them up to speed. Now, when it came to the executives, it was much harder. So executives really parlay in languages. They never get their fingers dirty, rolling up their hands and getting on keyboards and things like that. They sit back and they use language to parlay concepts. And the strength of their social status within the organization is how well those concepts actually lead the organization successfully. Now, that means there's a path to adoption here. The early adopters are things that those executives know and parlay in language, those conceptual ideas, that they're well adept to parlay those linguistically. Those that are adjacent that could become well known are high potential adopters. Those outside of that will never be adopted. And that is where AI used to be. And that is absolutely where quantum computing is now. And so you need to shift left from this poorly understood space to a well understood space, or at least close enough. Otherwise, I don't care what technology it is, there's zero adoption in this space. So this is important, especially in the business development stage, to sell quantum or anything else into a business organization. The other thing that we've learned is that mapping real world problems to quantum circuit algorithms is very, very difficult. This is one of the linchpins. The first linchpin is that the technology, the material science to hold subatomic particles long enough to do information processing on them is the choke point. It is the choke point for quantum. The next one is the immaturity of the tools that we use to map real world problems to circuit boards, to quantum circuit boards, to the solutions. It's a horribly difficult problem. It's very, very immature, and no one in the industry does this well, no matter who tells you that they do. From the big players to the small consulting companies, this is one of the hardest problems out there in all of quantum, and don't let anybody tell you differently. So another thing we've noticed in our venture here is that there's a problem for selecting quantum problems. There's a process for selecting quantum problems in their solution candidacies. So if the problem is known to be unsolvable or suboptimal on any classical computer, those are the kind of problems that you can shunt along and say, yeah, this is one we want to try to do with quantum. If it's not, if it's solvable on a classical computer, don't worry about it. Don't solve it on a quantum computer. You're wasting your time, unless there's lessons to be learned from that. Now, once you find that problem that can't be solved classically, then that problem also needs to be mappable to known quantum algorithms, stuff that people have done already, like Shor's algorithm and Grover's algorithm, things like that. And only after that is that problem a reasonable candidate for experimentation. And even then, you don't know if you can solve it until you try. So this is a process out there for selecting problems. Another thing that's of interest is, from a managerial standpoint, is that quantum is an Opex cost. It's not a CapEx cost, meaning it's an operational expense, not a capital expense. You don't have to put a quantum hardware in your basement to start using quantum. You can rent quantum software from AWS or many of the other cloud providers out there who have a plethora of different architectures under the hood. And you can get started very inexpensively, even more so if you use the free simulators, and we do that a lot. You can begin learning quantum without spending any money at all. And that's a very prudent way to do. You should do it in the simulators first, and then go to the actual hardware. That's going to allow you to learn inexpensively, and that's the preferred best practices path of learning. And now, last but not least, we found great efficacy and great enhancements with our strategic alliances. You have to go out there and find folks out there who are having a strategic point of view with quantum vis-a-vis business. And that's one of the folks that we've connected with. I'm in the group here as well, this Quantum Strategy Institute run by Brian Lenihan. He's got a number of books out in this space. But the idea to have a think tank that's bent on business and adoption of this quantum space and takes a business strategic bent to it is really what's going to help you understand how to sell to your own internal constituencies, because they're looking at all those key areas that are pain points and how to overcome them. This is a great way, as well as any other institute you can get your hands on, to connect with, to grow, learn and grow. And so I would highly recommend that. And with that, we are at question and answers. And I will stop sharing just a little bit early and go back to our wonderful hosts here, and for continuing as maitre d'. Thank you all for coming.
Wow, Matthew, that was amazing. Thank you so much. I know this virtual audience is going wild with virtual applause. That was incredible. And for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection requests and take some time to check out our awesome exhibits. Thanks so much, and we'll see you around.